Hey everyone, welcome to this video on Site Reliability Engineer interview questions and answers. SREs are the backbone of modern infrastructure. They are responsible for keeping large-scale systems reliable, scalable, and highly available. It's a unique blend of software engineering and operations focuses on automation, monitoring, incident response, and performance tuning. In this video, I have divided SRE interview questions into three categories along with the clear, practical answers that interviewers are actually looking for. The first 10 questions are for the beginners, the second 10 questions for the intermediate candidates who have 1 year of experience, and the last 10 questions for advanced candidates. Companies like Google, Amazon, IBM, Microsoft, and top Indian tech firms are hiring SREs to maintain uptime and manage complex production systems. According to the job portals, there are thousands of active SRE job openings in India right now, and the demand is high. As per Glassdoor and Ambition Works, entry-level SREs in India earn around 8 to 12 lakh rupees per annum, while experienced professionals can go up to 30 lakh rupees per annum, especially with the cloud and DevOps experience. So stay till the end and take notes. And if you find this video helpful, don't forget to like, share, and subscribe for more tech interview content. And if you want to learn paid SRE course with certification, then check out our course where we cover latest industry curriculum, hands-on projects, labs, mock interviews, and more. Check the link in description below. Let's dive in and get you one step closer to becoming a site reliability engineer.
Hi everyone, this is Arvind from Mindmajix, and today I welcome you all to this amazing session on SRE interview questions. So guys, this is one such topic around which we have been receiving a lot of requests from our viewers. So that's why we decided to come up with this video, and in this particular video, we will be covering roughly around 30 questions. And these 30 questions have been divided into three categories. Like the first 10 questions, they are meant for the beginners or the fresher candidates who have relatively less experience, or who are, they're about to join the IT industry. And the next set of questions, like the next 10 questions, they are for the intermediate candidates, like those people who have at least, roughly around 2 to 3 years of experience working into this SRE domain. And finally, we will be covering 10 questions. Those are the advanced questions. And those questions are meant for the experienced candidates, like, for those people who have at least, let's say, 4 to 5 years of experience working into the SRE space. So that's the agenda for today's session. And before moving ahead, I want you guys to subscribe to Mindmajix YouTube channel and also hit that bell icon so that you never miss an update from us. So without any further delay, let's get started with our first question. Yes, so guys, the first question is a very basic question. So the question says, what is SRE, or Site Reliability Engineering? So SRE is a discipline that has been developed by Google that applies software engineering principles to IT operations. So the main goal of SRE is to create scalable and highly reliable software systems. So unlike the traditional operations, SRE engineers write code to automate tasks, manage infrastructure, and ensure uptime. So it basically bridges the development and the operations by ensuring that new features do not compromise the reliability of the system. So this was a short and a crisp definition of what exactly is SRE, or Site Reliability Engineering. And guys, apart from this question, in the actual interviews as well, you might face a similar questions like what is SRE and how does it differ from DevOps? Okay, so many people have this confusion between SRE and DevOps as well. So let's clear that confusion as well. So like I told you, SRE is a discipline that applies software engineering principles to operation, and this is done to create highly reliable systems. On the other hand, DevOps focuses on fostering collaboration between the development and the operations. SRE emphasizes on automating tasks, managing risks, and ensuring system reliability. In other words, SRE is an implementation of DevOps with a strong focus on scalability, monitoring, and automation to maintain the system performance. I hope this clears the difference between SRE and DevOps as well. And now let's move to the next question. So the next question says, what is an SLA, SLO, and SLI? So guys, these are the very important metrics in SRE. And now let's talk about them one by one. So SLA is nothing but the service level agreement. So this is basically a contractual agreement between a service providers and the customers on the expected service performance. In case of breaches of SLA, this may lead to penalties as well. On the other hand, if you talk about the SLO, which is the service level objective, so this is a specific target for service reliability, such as maintaining 99.99% of the availability. And if you talk about the SLI or the service level indicator, so this is a measurable metric like latency, error rate, or uptime that is used to track the performance of a system. So guys, in SRE, the SLIs and the SLO guide the service reliability efforts, whereas the SLS help align with the business expectations. This clearly explains what is SLA, SLO, and SLI. Now let's move to the next question. And the next question says, what is a runbook? So a runbook is a documented procedure for handling specific tasks or incidents. Basically, it helps on-call engineers to take consistent action without escalating. For example, a runbook for disk space issues may include checking the disk usage, removing old logs, and restarting the service. The next question is, explain the concept of toil. So guys, toil is basically a manual, a repetitive and automable work that has no long-term values and scales linearly with service growth. Like if the reboot of the servers or manual deployments are performed repeatedly. Further examples include manual deployments or restarts. So basically, reducing toil frees up the engineers to focus on engineering tasks that improve the reliability. So SREs tend to minimize the toil with automation, concentrating more of their time on high impact activities that maximize the performance and the reliability. And lastly, the overall efficiency improvement. So guys, the next important question is, what is the difference between monitoring and observability? So monitoring and observability are essential in SRE roles, and they ensure early detection of issues. So if you talk about monitoring, so this involves collecting predefined metrics and alerting on known failures. So basically, monitoring provides real-time data on system performance, allowing us to set alerts based on predefined thresholds. And now if you talk about observability, so this means having the tools and the data, such as logs, metrics, and traces, to ask and answer the questions about system behavior, especially those related to unknown issues. So observability goes beyond monitoring, and this provides insights into system behavior to understand why the issues occur in the first place. So just to give you an example, so monitoring tells you the CPU is high or the CPU usage is high. Observability helps you determine the why behind it. So in SRE, both are crucial for identifying the potential problems, diagnosing the root causes, and taking proactive actions to maintain the system reliability. The next question is, so guys, this question is basically a scenario based question. So in actually interviews as well. So, apart from the theory questions, the interviewer will test your knowledge by asking you a lot of scenario based questions. So guys, through the scenario based question, the interviewer comes to know whether you have, the real hands on knowledge and, how well are you able to handle the scenarios and what is the approach that you follow while handling any particular scenario. So basically, they want to test your problem solving skills. Okay. So in this particular question, there's a scenario. So let's say your web app is loading pretty slowly. And in order to counter this, what are the steps that you will take? So guys, if your web app is loading slowly, so what you can do is you can begin by checking the key metrics like latency, error rates, and response times to confirm the slowdown and understand the extent of it. So next, what you can do is you can review logs for any timeouts, exceptions, or unusual error patterns that could hint at the underlying issue. So over here, you can use application performance monitoring or APM tools such as Datadog or New Relic or Dynatrace to trace the requests and pinpoint which services or functions are causing the delays. So further, you can investigate potential backend bottlenecks such as slow database queries, cache misses, or overloaded APIs, and also evaluate if higher traffic is overwhelming the system. And lastly, what you can do is you can verify if there was a recent deployment or a configuration change that could have introduced performance regressions and consider rolling back if necessary. So addressing these steps systematically helps you restore the app performance efficiently. The next question is, what are some of the common tools used by SREs? So guys, the interviewer basically wants you to, or the interviewer wants to understand what are the tools that you have hands-on experience with, or what are the tools that you can, you have the knowledge of their underlying working, or, the architecture and so on. So basically, while answering these questions, you should mention, like, apart from the tools, you should also mention the purpose of why, like where those tools are used for. So over here, as you can see on the screen, for monitoring purposes, you can use tools like Prometheus, Grafana, and Datadog. Now, for the logging purpose, what you can use is the ELK stack, which is basically Elasticsearch, Logstash, and Kibana. And for the alerting purpose, you can use tools such as PagerDuty or OpsGenie. And for the purpose of automation, there are numerous tools such as Ansible, Terraform, Jenkins. So basically, these tools help you automate operations, monitor the systems, and ensure reliability. So guys, the next question is again a scenario based question. So let's say you receive an alert at 3 a.m. in the morning. And now, how do you respond to this alert? So guys, basically, when you receive an alert at 3 a.m. in the morning, the first step is to acknowledge the alert to prevent multiple team members from responding to the same issue. So after that, what you can do is you can check the system dashboards, logs, and metrics to assess the scope and the root cause of the problem. You have to determine whether the issue is impacting the users or just an internal service to prioritize your response. So if it is critical, try to apply a quick fix or perform a rollback to restore the service as quickly as possible. So once the issue is mitigated, so you have to document all the actions that you have taken, including observations and resolutions, to support the post-mortem process and future incident response improvements. So if necessary, what you can do is you can escalate to other team members or the stakeholders depending upon the severity of the incident. So guys, the next question is, what is a blameless postmortem? So guys, blameless postmortem is a retrospective after an incident where the focus is on understanding what happened and why rather than assigning the blame. So basically, it promotes a culture of learning and continuous improvement. So there are key components over here such as timelines, impact, root cause, remediation, and action items. The next question is, what are error budgets? So an error budget is the acceptable amount of a failure a service can have in a given period, calculated as 100% SLO. So basically, an error budget is how much downtime a system can afford without upsetting the consumers, or it is also known as the margin of error permitted by the service level objective or the SLO. So basically, the error budgets encourages the team to minimize the actual incident and maximize innovation by taking risks within the acceptable limits. So basically, they help you balance innovation as well as the reliability. So for example, if the SLO is 99.9%, the error budget allows 43.2 minutes of downtime per month. So guys, with this, we have covered the basic or the beginner level questions related to SRE. And now question number 11 onwards, till question number 20, we will be covering the intermediate level of questions. So now the next question over here is a scenario based question. So let's say your SLO is consistently violated, and once that is happening, what will you do in such a scenario? So if your service level objective or the SLO is consistently being violated, the first step is to analyze the recent incidents to understand what types of failures or degradations have occurred and when. For that, you have to look for the patterns or the recurring root causes such as infrastructure failures, application bugs, or sudden traffic surges. So once identified, you may need to pause new feature releases temporarily to focus on improving system reliability and reducing the risk. So it is important to collaborate closely with the development team to address the underlying code or the architectural issues contributing to the instability. At the same time, you can revisit your alerting thresholds to ensure that they are not too lenient or too aggressive, which could mask or exaggerate real problems. Apart from this, what you can do is you can conduct a capacity review to determine if your system is operating near its limits and consider scaling the resources or optimizing the performance. Next, what you can do is you can use monitoring tools to check or to verify if they are accurately capturing the relevant service level indicators or the SLIs. The overall goal is to stabilize the system, protect the user experience, and bring your reliability metrics back within the defined SLO. The next question is, how do you ensure zero downtime deployments? So to ensure the zero downtime deployments, the first step is to implement the rolling updates. So over here, the new application instances are gradually deployed while the old ones are still serving traffic, minimizing the user impact. So this can be managed effectively in platforms such as Kubernetes, which uses readiness probes to shift traffic only to the healthy pods. So another strategy could be canary deployments, where the changes are introduced to a small percentage of users and monitored for issues before a full rollout. So for larger updates or architectural changes, blue-green deployment can be used where a new version is deployed to a separate environment and traffic is switched over only after thorough testing. So it is also essential to have health checks and monitoring in place during the deployment to detect the anomalies early. So apart from this, you can use feature flags that allow you to deploy code safely and toggle new features on and off without redeploying. Additionally, having automated rollback mechanisms can help you revert to a stable version if something goes wrong. So combining all of these strategies ensures high availability and a smooth deployment experience without the service interruption. The next question is, explain the incident response lifecycle. So guys, whenever there's an incident that has taken place, so there's a life cycle that the incident goes through. And in this particular question, you have to explain what are the life cycle phases or the steps through which the incident goes through. So the first step or the first phase of the response life cycle is the detection. So basically, you have automated alerts or user reports that detects the incident. So the next step is the response. So basically what you have to do is, first you have to acknowledge, and then you have to investigate and then mitigate the incident. The next step is the communication. So once the incident has been detected and you have also responded, next step would be the communication. So what you have to do is you have to communicate this to your team members or the stakeholders. You have to inform them about the incident that has taken place. And the fourth step is the resolution. So basically what you have to do is you have to apply a fix and verify the service. So you have to, resolve this incident, and you have to make sure that, this does not have a long lasting impact on the systems. And then comes the final step, which is the postmortem. So basically over here, you have to analyze the root cause, document the lessons, and implement the improvements. The next question is again a scenario based question. So let's say the database latency has increased, and what are the steps that you will perform in order to respond to such a scenario. So if a database latency has increased, the first step is to check the database server's CPU and memory usage to determine if the resource exhaustion is contributing to the slowness. So high usage could indicate inefficient queries, lack of indexing, or increased load. So after that, you have to use the explain statement to analyze slow queries. So if the database latency has increased, the first step is to check the database server's CPU and memory usage to determine if the resource exhaustion is contributing to the slowness. So high usage could indicate inefficient queries, lack of indexing, or increased loads. So after that, you have to use the explain statement to analyze the slow queries, which helps identify missing indexes, full table scans, or poorly optimized joins that may be causing the delays. So it is also important to review any recent schema or indexing changes as these might have unintentionally degraded the performance or locked the tables. Additionally, what you have to do is you have to analyze the connection pool to check if the application is hitting its maximum connections or if there are idle connections piling up, which can lead to queuing and timeout issues as well. So if these investigations correlate with a recent deployment, so you can consider rolling back the deployment to see if the performance improves, especially if the changes affected query logic or the ORM behavior. So over here, monitoring tools like PG stat statements for PostgreSQL or performance insights for the RDS, these tools can help you track the query performance over time. So these steps together will help you isolate the root cause and guide appropriate optimizations or the fixes. The next question is, what is chaos engineering? So chaos engineering involves injecting faults into the system to test the resilience and recovery. So by simulating unexpected events such as server crashes or network disruptions, we can observe how our system handles failure and improve the fault tolerance. So over here, tools like Chaos Monkey can help you automate these experiments as well. So chaos engineering is invaluable in SRE as it highlights the weaknesses and allows us to design systems that can withstand real-world disruptions. For example, what you can do is you can terminate the pods or simulate the network loss to ensure systems auto-heal and alerts correctly. The next question is, what is the role of automation in SRE? So automation is at the core of SRE, and this can help you eliminate repetitive tasks, reduce the errors, and free up the engineer's time for high-level work. Automating tasks like deployments, monitoring setup, and incident responses ensures the consistency and the speed, and thereby reducing the manual intervention. So by implementing infrastructure as code or IAC and automating testing and the rollbacks, SREs can minimize downtime and maintain system reliability effectively. The next question is a scenario based question. So let's say a noisy neighbor pod is impacting others in your Kubernetes cluster. So what steps will you take in order to counter this problem? So when a noisy neighbor pod is consuming excessive resources and impacting the performance of other pods in your Kubernetes cluster, so the first step is to set the proper CPU and memory requests and limits for all of the pods. So when a noisy neighbor pod is consuming excessive resources and impacting the performance of other pods in your Kubernetes cluster, the first step is to set up proper CPU and memory requests and limits for all of the pods. So this ensures that each pod gets a fair share of resources and cannot starve others. After this, what you have to do is you have to implement the node affinity and anti-affinity rules to control the pod placement. So basically this helps in keeping the resource heavy workloads separated from the latency sensitive or critical services. Additionally, taints and tolerations can be used to dedicate specific nodes for certain types of workloads, preventing noisy pods from being scheduled alongside more important ones. So it is also a good practice to isolate the critical services in their own namespace or nodes, giving them a more controlled environment with dedicated resources and tighter security boundaries. So another key step is to leverage the Kubernetes QoS or the quality of service classes, which prioritize pods during resource contention. So guaranteed pods are less likely to be evicted or throttled than best effort ones. So monitoring and adjusting these configurations regularly based on the workload behavior is essential. So together, these measures ensure better resource isolation and overall cluster stability. The next question is, how would you handle an incident in production? So guys, SREs are often responsible for the incident management, and when handling an incident in production, basically you must prioritize 3 steps, and those 3 steps are detection, containment, and resolution. So firstly, you have to use monitoring tools to identify the issue. Then you must contain the impact by isolating the affected components or deploying a hotfix if possible. Next, you must work with the team to diagnose the root cause and implement a solution as soon as possible. Finally, when all of this has been done, You have to conduct a post-incident review to document findings and implement preventive measures. The next question is, can you describe a time or a situation where you have improved a system's reliability? So guys, this is again a scenario based question, and like I've told you previously, like these questions are for the intermediate level candidates, like those people who have at least 2 to 3 years of experience working into the SRE domain. So the answer to this question, it is very subjective. It will differ from candidate to candidate. And in your previous organizations, wherever you have handled such kind of situation or this kind of scenarios, you have to explain the same in this question as well. Let's say you can answer this question like this: in my previous role, our system had a frequent downtime due to unoptimized configurations and inconsistent deployments. So thereby I implemented infrastructure as code with Terraform to standardize our infrastructure and set up automated monitoring using Prometheus and Grafana. So apart from this, what you can also say is you have created a canary deployment strategy for updates, which reduced the impact of the failures. As a result, the system uptime improved by 15% and incident response time decreased significantly as well. So this was just a small example wherein you have clearly described a scenario or a real-time incident where you have improved the system's reliability. And what are the steps that you took in order to improve the reliability? I hope everyone is clear with this question and the answer that I've just mentioned. And now let's move to the next question, which is again a scenario based question. So let's say you're onboarding a new microservice. So once that is being done, what are the observability steps that you will take? So guys, whenever you onboard a new microservice, the first step is to define the clear SLIs, or the service level indicators, such as the latency, error rate, and availability, and then derive appropriate SLOs, or the service level objectives, based on business expectations and user experience. So once the objectives are set, what you can do is you can implement observability by instrumenting the service with metrics, logs, and distributed traces using tools like OpenTelemetry, Prometheus, and Jagger. So these allow you to monitor service health and debug issues effectively. Next, what you can do is you can integrate the service with centralized monitoring tools such as Grafana, Datadog, or ELK Stack to visualize and analyze this telemetry data in real time. Next, what you can do is you can set up the alerts for key indicators like high error rates, slow response times, or memory usage spikes to proactively catch issues before they impact the users. So it is essential to simulate the loads and the failure scenarios using tools like Chaos Monkey to validate that your observability setup captures abnormal behavior accurately. You have to ensure that the logs are structured and traceable across the services to support root cause analysis. So this end-to-end setup ensures that the microservice is production ready, observable, and resilient from day one itself. So guys, with this, we have covered the intermediate level of questions for SRE. And now the next 10 questions, they are meant for the advanced people, or, these questions are a bit tougher than the previous questions. Our next question, which is, why is horizontal scaling preferred? So guys, before answering this question, there are two types of scaling that are available, which is the horizontal one and the vertical one. So if you talk about the vertical one, vertical scaling adds resources to a single instance, often used for stateful services. So over here, you use the auto scaling based on metrics to maintain their performance under load. And now if you talk about the horizontal scaling, so horizontal scaling basically adds more instances or pods useful for the stateless services. So now by adding several logical resources, a system's size can be increased horizontally. And to do this, you can either add more virtual machines or containers to each of the hosts. So additionally, it is possible by adding many hosts at once as well. So this is also known as scaling out as a result of the increase in the system. And now let us come to the main question. Why is the horizontal scaling a preferred choice? So basically, due to the system's load and running time, This is the preferred method, and the biggest advantage of horizontal scaling is that it is expandable. So horizontal scaling or scaling out has numerous other benefits as well, like you need less money upfront to implement the horizontal scaling, and you can also get significantly lower administrative costs with this preferred method. And last but not the least, horizontal scaling facilitates simpler scalability as the demand rises. So it is very much easy to scale up when the demand rises and scale down when the demand decreases. So that is why horizontal scaling is a preferred choice. The next question is again a scenario based question. So let's say your services or your service shows latency spikes under load. So in order to counter this situation, what is the approach that you will follow? So if your service experiences latency spikes under load, so the first step is to profile the application using the application monitoring tools like New Relic, Dynatrace, or the Datadog to identify which components or functions are slowing down. So these tools provide deep insights into the request traces, slow endpoints, and the bottlenecks as well. Next, what you have to do is you have to analyze the garbage collection, pauses, and the thread contentions, as inefficient memory management or too many concurrent threads can delay the response times under pressure. It is also critical to review the database and the cache interactions, since slow queries, missing indexes, or cache misses often contribute significantly to increased latency. Next, what you can do is you can run load tests using tools like JMeter that will help you simulate high traffic scenarios and validate the system's performance and scalability under stress. So based on the findings, what you can do is you can introduce caching for frequently accessed data and batch processing for high volume operations to reduce the repeated processing and the IO overhead. So optimizing service dependencies and external API calls is also pretty much essential. So finally, what you have to do is you have to monitor the changes post optimization to ensure the latency improves without introducing regressions. The next question is, what is the difference between blue-green and canary deployments? So basically, blue-green deployment involves running two identical environments named blue and green. So one environment handles live traffic while the other is used for testing the new releases before directing the traffic to it, making it easier to revert if necessary. In contrast, if you talk about the canary deployment, so this strategy introduces the new version gradually to a small group of users before a full release, and this enables step-by-step validation and reducing the impact of any potential issues. The next question is, what is capacity planning? So capacity planning ensures infrastructure can handle the projected load. So over here, you use the past usage data, seasonal trends, and growth projections, and you incorporate the safety margins and monitor for over or under provisioning as well. So once you explain the definition of what is capacity planning, the interviewer might also ask you, like, how do you approach any scenario related to capacity planning, or how have you handled capacity planning previously? So to answer that question, you can say that you approach capacity planning by analyzing data on resource usage, estimating future demands, and simulating different load scenarios. So for that, you can use tools like Grafana and AWS CloudWatch for monitoring trends. And you can also mention that you have worked closely with the development team to understand the upcoming releases or expected spikes in traffic. Apart from that, you can say that you have implemented auto scaling policies and you have run load tests periodically to ensure that the systems are prepared for growth and high demand periods. The next question is a scenario based question. So let's say you're getting frequent noisy alerts, and now what will you do to resolve this situation? So whenever you face frequent noisy alerts, the first step is to review and fine tune the alert thresholds to ensure that they are aligned with meaningful service degradation, not minor fluctuations. So many alerts are triggered by overly sensitive settings, so adjusting these can drastically reduce the noise. So it's also important to suppress the low priority alerts that do not require immediate attention or have minimal user impact. So these can be sent to a dashboard or a daily summary instead. So to avoid being overwhelmed by repetitive alerts, what you can do is you can implement the alert deduplication and grouping. So which consolidates similar or identical alerts into a single actionable notification. Apart from that, what you can also do is a user experience or a system reliability. So regularly reviewing your alerting rules and outcomes ensures that continuous improvement of the system is in place. So this process not only enhances alert quality, but also protects on-call engineers from burnout. The next question is, describe how would you create a post-incident report. So basically, guys, the interviewer wants to assess your skills in handling the post-incident analysis, which is a very crucial part of an SRE candidate. So post-incident report should include a clear timeline of the events, the root cause analysis, the impact of the incident, and the steps taken to resolve it. So you can also add lessons learned and recommended actions to prevent similar issues in the future. So by discussing these findings with the team, you must ensure that everyone understands the incident, that we implement measures to improve the reliability. So documentation and communication are essential for continuous improvement. The next question is, how do you manage software deployments to minimize the risk? So to reduce the risk of deployments, you can have strategies such as canary releases, where changes are rolled out to a small subset of users before a full rollout. So blue-green deployments allow switching between the two identical environments, thereby reducing the downtime. Apart from that, automation and continuous integration pipelines also help you ensure smooth and error-free deployments. The next question is, how do you promote SRE culture in a new team? So guys, there are a few things or few of the best practices that you must follow in order to promote the SRE culture in the new team. And some of them are listed on the screen, as you can see. So first of all, you have to establish SLAs and SLOs clearly, and that too very much early in the project. Next, what you can do is you can share the on-call duties. So on-call responsibilities involve the readiness to react to an incident within a certain timeline. So we make sure that you have monitoring tools available and you are aware of the escalation paths as well. So while on call, we must maintain concentration or the focus to find the root cause of the problem, resolving it in the shortest possible time, and ensuring a seamless handover to the next team member whenever required. The next best practice would be encouraging blameless retrospectives. So here, a culture of blamelessness is more on learning from the failure rather than holding a person liable for the cause. So it enhances open communication whereby teams can take time to scrutinize incidents without the fear of reprisal from the punishment. Next, what you can do is you can track toil and automate it. And last but not the least, you must celebrate small wins in reliability. So guys, these are some of the best practices that you can follow in order to promote the SRE culture in your new team. The next question is, what role does Kubernetes play in SRE? So Kubernetes plays a crucial role in SRE by providing a powerful platform for automating the deployment, scaling, and management of the containerized applications. So one of its core strength is self-healing, where failed containers or pods are automatically restarted or rescheduled, reducing manual intervention and improving the uptime. Kubernetes also supports rolling updates and rollbacks, and this enables the SREs to deploy new features with minimal risk and revert quickly if an issue arises. So through horizontal pod auto scaling, it ensures that the applications scale based on real-time demand, maintaining performance during the traffic spikes. So Kubernetes enhances the resource efficiency by intelligently scheduling workloads across the available nodes using resource requests and limits. So Kubernetes also improves the observability and reliability through built-in health checks, readiness probes, and integrations with monitoring and logging tools as well. So guys, these are some of the key, you can say, the the capabilities or the things that you can establish with Kubernetes in the SRE space. The next question is a scenario based question. So let's say you have to design an alerting for a global e-commerce application. So to do so, what is the strategy that you will follow? So when designing an alerting strategy for a global e-commerce application, the first step is to implement region-specific synthetic checks to monitor the critical functionalities like checkout, login, and search from different geographies. So this helps detect the location-specific outages or latency issues before users report them. So it is crucial to alert on symptoms such as increased error rates or high latency rather than technical causes like CPU usage. So this ensures that the alerts are tied to the user experience. So next, what you can do is you can use routing alerts based on time zones to ensure that on-call engineers in appropriate regions are notified during their working hours, reducing fatigue and improving the response times. Apart from that, you can incorporate SLO based alerting that will help you avoid alert fatigue by focusing only on breaches that impact agreed service levels. For example, instead of alerting on every error, you alert when error rates cross the threshold that would affect your SLOs. So it is also important to review and tune the alerts regularly to eliminate false positive, outdated conditions, and ensure critical paths are covered. So this holistic approach results in more reliable, scalable, and actionable alerting system. So guys, with this, we have covered the questions for SRE. I hope you guys have enjoyed this question. And if at all you have any doubts or queries related to any questions that we have covered in this particular video, you can write your queries in the comment section and we will try to resolve those as soon as possible. So guys, thank you so much for being with us and I wish you all the very best for your upcoming SRE interview.